Okay, so I just wanted to finish this lecture by directing everyone to the area on my site where I've posted a Sage calculator that might help with linear approximations. So the main thing in these is calculating the Jacobian derivative. And so there is a syntax for doing this in Sage. If you input Jacobian, open parentheses, f, where f represents your function, followed by a list of the variables that you want to take derivatives with respect to, this will call the Jacobian derivative of the function f with respect to those variables. So if you look at the predefined code here, I have started by initializing variables x, y, z, and then I've defined a function of x, y, and z as a vector where it looks like I have 1, 2, 3 outputs. So the Jacobian derivative that I'm about to calculate should be a 3 by 3 matrix. And so I've input these coordinate functions. And so I'm also defining a variable which is in all caps called variables, which tells me the variables that I'm using here. So this is x, y, and z. So if I click evaluate and scroll down, what pops out is the function I input, so I can check whether or not I made any errors. And then the Jacobian derivative of that function is here. And as you can see, since this is a function from R3 to R3, the Jacobian derivative is a 3 by 3 matrix. So keep in mind, you can change this to your liking. So maybe you want variables p, q, and r, and I'll just make up some outputs here. Maybe p times q, x of p times q, r times cosine of p, r times sine of p squared. So here I'm defining a new function. This is f, and the variables here are p, q, and r with 1, 2, 3, 4 outputs. So this should end up being a 3 by 4 matrix, and a 4 by 3 matrix. And I'm going to define now the variables here instead of x, y, z as p, q, r. If I click evaluate, it should now update with the new data. And as we can see, I have my formula for f here, which is now in terms of p, q, and r. Again, we have those 3 inputs with these 4 outputs. So my Jacobian derivative is a 4 by 3 matrix. So hopefully that helps you while you're doing your calculations. Please use this to check your work.